Hello everyone, I am Shakir Samantapudi, and today I will be walking you through my blog uh, titled Intersection of Pattern Mining and Explainable AI. So this blog dives into how explainable AI techniques can enhance the transparency and trust in the pattern mining models, especially when we are working with critical data in the domains of retail, fraud detections, and healthcare. So here I will be providing a link which will be giving you many beneficial insights to learn about pattern mining and explainable AI and the intersection of both with some code snippets, outputs, graphs, and some materials to learn this pattern mining and explainable AI techniques. So, uh, to introduce this concept, let us see why this concept, pattern mining and explainable AI, are coming together. Because in today's fast-paced AI landscape, one challenge is making AI decisions understandable. So here, let us uh, discover what is pattern mining first. So pattern mining will be helping us to uncover the hidden patterns in large datasets. But without explainability, even the best pattern might be ignored due to the lack of trust. So this is where explainable AI or XAI will be coming into the picture. So XAI will be offering the interpretable insights into complex models. So this block will be exploring their intersection. So let us see what is explainable AI with pattern mining. So first let us see what is pattern mining. Pattern mining is a data science technique which will be uh, aiming to find the meaningful patterns, associations, or trends in the large datasets. So it is widely used across many domains. So let me walk you through a few real-world applications of them. So first, it is market basket analysis. Market basket analysis. So uh, a classic example is retail. Suppose a customer buys a bread and also buys butter. So this association can help with inventory planning, store layout, and personalized offers. Even a name example will be if customer is frequently buying milk and eggs together, the store might display them together or offer combo discounts. So this market basket analysis will be helping the retailers uh, to arrange the similar things in the store close or away and to manage the inventory in an optimal fashion and to provide discounts on the frequently purchased items and also make product recommendations to the clients. And the next application is fraud detection. Fraud detection that it will be in banking or e-commerce. So here the pattern mining helps to detect the anomalies. If a user usually makes small local purchases, but suddenly he's making a high value transaction overseas, so that's a suspicious thing. So by tracking sequences and behavior of the user, the pattern mining improves the fraud detection systems and help to trigger the alerts early. So let us also see the third application, which is in medical domain. So in medical domain, mining the medical records can uncover the patterns that connect symptoms with diseases. For instance, diabetes with high BP and certain cholesterol levels might be at higher risk for kidney issues. So recognizing such patterns lead to earlier intervention of diseases and better outcomes to a patient. So we'll be moving to pattern mining techniques. So here pattern mining will be coming in many flavors. I have covered the most widely used types and their applications. So first, frequent pattern mining. Frequent pattern mining, here we aim to find the item sets that occur frequently. So the first thing is a priori algorithm. So a priori uses the idea that if an item set is frequent, then all its subsets must also be frequent. So this helps in pruning large search spaces. And it works by iteratively identifying the item sets that meet a user specified minimum support and uh, also to mind the association rules, it will be uh, making high from the minimum confidence threshold. So this algorithm will be computationally feasible for large datasets. So let us see FP growth now. FP growth builds a compressed structure called FP tree. Like instead of generating candidates like a priori, it mines the frequent patterns recursively by saving time and memory. So this approach reduces the memory and speeds up the mining process. So this is well suited for large datasets too. And it is also efficient in learning association rules. So then we will be going to closed and maximal pattern mining. So both of the things, closed and maximal patterns, are ways to reduce the redundancy in pattern mining. So if we see closed frequent patterns, these removes the subsets that don't offer additional insights because it is ignoring a frequent pattern that is not part of any bigger pattern that is appearing just often. So if AB and ABC are frequent, in this example, if AB and ABC are frequent, only ABC would be considered because AB is also a redundant item set in ABC. So what is maximal pattern then? Maximal pattern are the largest frequent item sets without any supersets. A frequent item set that is not a subset of any larger frequent set. It can be told in any of the way. A frequent item set that is not a subset of any larger frequent item set or largest frequent item set without any supersets. So the example will be like in medical records, a maximal pattern might be a set of symptoms that always occur together without additional symptoms. And let us see what is sequential pattern mining then. Sequential pattern mining, it is a pattern mining technique. This captures the order and finds the recurrent pattern. So this method concerns with a order. So for example, how user moves through an app or purchase journey. So this can be a sequential pattern mining technique. So in that we are having two pattern mining techniques. One is GSP, generalized sequential pattern mining. So that is an algorithm which is based on a priori. It will be starting with one sequence and grows towards, and it will start by searching the dataset for every common one item sequence. After that, it creates candidate two sequence and sorts them according to how supportive they are. And until no more frequent sequences are discovered, this process iteratively keeps going on while lengthening the sequence. So second one is prefix scan. It is also an efficient algorithm used in sequential pattern mining to discover the sequential frequent patterns. So this avoids generating candidate keys by projecting only the relevant suffixes, making it faster. It will be like it grows patterns by extending the frequent prefixes and creates the projected database to search only relevant suffixes. So for an example, uh, user and their actions are projected below. User one is opening the app, viewing profile, and sending messages. User two opening app, view profile, opening opening nothing. So user three opening app, browsing feed, and liking the post. So the common thing here is opening app and viewing profile is a common pattern here. So then we'll be moving to rare and negative patterns. Sometimes rare patterns are more critical than the frequent ones, especially in the domain of fraud or rare disease detection. Suppose it, for an example, uh, frequent patterns are if there is a battery failure, there will be a engine failure in mostly in electric vehicles, and if there is a brake wear, so then will be a tire damage. But the rare pattern is like airbag sensor and sudden brake lock. So it is very rare. So then we'll be moving to colossal pattern. Colossal pattern mining, this deals with very large item sets that still occur frequently. For instance, customer might buying over 10 plus items in a one go. If this pattern is repeated often, it becomes a colossal pattern. So let us move to this example. So this is a colossal pattern. So we'll be moving to multi-level and multi-dimensional pattern. So multi-level mining moves from the general view to the specific view. So instead of examining the data at single level, such as individual projects, so it will be investigating the patterns in hierarchical manner, starting with the basic category and ending with specific objects. So this is the basic category, level one, dry fruits, dairy. But the detailed item level is good life cashew, Amul paneer, less Indian magic masala. So this is the most specific pattern. So let us see what is explainable AI when we need it. So before it, we'll be seeing what is multidimensional. So multidimensional mining explores the patterns across multiple fields like age, income, category, etc. So here you can see the example. So this log will be provided as a link in the description, so it'll be easy to view here. So we'll be seeing what is XAI. XAI is a technique where we are aiming to unlock the hidden meanings of a complex AI model and offering the understandable and clear justification of the result. To build the trust and enhance the accountability, transparency, and fairness and identification of bias, and debugging and enhancement and adherence to the regulations. So we'll be seeing Lime and their working, SHAP and their working. So Lime will be telling that how it has arrived to a certain prediction in a model agnostic. So, for an example, an classification task of images in a deep learning algorithm identifying a zebra. So, the line tells us uh, when it has obscured the portions of the image, it has identified the stripes. So, the model will be predicting to zebra. If there are no stripes, it is not zebra. So, SHAP. SHAP is based on a game theory. So, each feature is viewed as a player, and the reward is the model prediction. So, this tells us the relative contribution of each feature to the prediction. Suppose when it is being compared to a party which was between a friends and they went to a restaurant, and so it was compared to allocating a meal bill among friends according to who paid the most, the contribution. So this is the example, more detailed example of credit scoring, and this is the way Lime works. It takes the specific prediction and it perturbs the input and fits into a simple model and shows the patterns influence the decision. So if we see like this, uh, if uh, P1 pattern 1 in operation at 2 a.m. and P2 pattern 2 the email address was modified. Pattern 3 made a significant acquisition. So according to model there is high fraud risk. So P1 pattern 1 working at late night will contributing plus 60% of the decision to high fraud risk. And P2 email address was modified. So these two 60% and 25% contribution was causing towards the high fraud risk. So here in this link, you will be finding the code intuition for the Apriori and frequent pattern algorithm. So this is the example which was being used. So if we take this data set and keeping the minimum support zero point 0.4 and minimum confidence zero point 0.8, the rules will be these three. So the rules will be these three with corresponding support count and this. So we'll be seeing rule one. Rule one is if the client buys butter, then he buys bread with a support of zero point 0.6, confidence of 0.85, and the lift is 1.07. If you want to see what are the uh, uh, definitions of support, confidence, and lift, so please redirect to this link. You will be finding the insights there. And let us see this rule. What is the explanation of line here? So the line is contributing the values as the support, which is zero point 0.6, is contributing plus 0.017. So it is contributing some positive. And the confidence is 0.857. It is contributing plus 0.0071. And the lift is contributing 0 to be strong. If the rule is to be strong association rule, it is telling that these are the contribution values for it. So these are very contribution values are very small. So the model doesn't tell it strong. So see here, the support is zero point 0.6. It is pushing towards push towards strong. Confidence 0.86. It is slightly pushing towards strong, but not full. So lift is not high enough to push towards strong. But the combined probability is not ending up for strong. So it is less than weak. So the weak soft to max probability will be 0.66 and strong is 0.34. So this tells that because of these things, because of being this support and this confidence levels, we can say that this rule is weak with this probability of 0.66. Similarly for the rule 2 and rule 3. So the conclusion is combining the explainable AI and pattern mining will be guaranteeing us with many insights of transparency and interpretability. So we can uncover the valuable insights from the data with explainable and trustworthiness. So this intersection empowers better decisions in fields like healthcare, retail, and finance. So thank you for this opportunity. Please redirect to this page to gain additional insights. Thank you. Have a good day.